So the question is that given an array of integers, every element appears thrice. So n minus 1 by 3, there are numbers which appear thrice. So there are n minus 1 elements, or so they are arranged such a way that there are just n minus 1 by 3 uh, elements which are repeating thrice. Okay, and just the one element which is repeating once, we have to send that as the answer. This is the second part of a 3-part video series. As a solution to this answer, we have 5 solutions to the answer. The first and the second brute force solutions have been explained previously. Here the XOR thing will not work. I hope you understand, because 1 and 3, 1 repetition and 3 repetitions, both are odd in number. The one has to be, there has to be an even odd combination for the XOR to work, right? So I'd explained beautifully the past time. I think I have to explain it that way again. So let's just take a small example. If we have, let's say 3 3 1 1 3, so we have 2 here, 4 4 4. So the 2 should be the answer, right? Let's first assume there is no 2 in this question first, so as to understand what the solution is to this answer is. So I think I had asked you guys to understand from a hint that I had given previously. The hint was that we have to find a pattern which happens uh, at the sum of the individual bits at a given location, where there's a pattern, there's a characteristic to the sum which helps us find the solution. And so from the code you could have found out. If you have found out, then I appreciate that. If you haven't till now, I would ask you to go through it and try to find it out yourself. If you can't, then always there's an answer over here. You can just revert back here. So first let's remove this 2, right? So let's first write all of the answers here. So 4 is 100. We should have 32 bits, but I'm just mentioning the last 3 bits because that is going to suffice for all of this. The rest are going to be 0 anyways. The some are going to be zeros. So then 2 3 3 4 1 3 1 and 4. Okay, so let me remove 2 from here. Which one is it? Quickly, let me just take it aside. Okay, just take that 2 aside, and let me just find the sum after doing all this calculation. So we have here 1 2 3 4 5, what, 3, one is present once. We should have another one here. See, I could get that there's some problem in the solution, so there should be another one here. So 0 0 1, let me do it. So 1 2 3 4 5 6, so the sum is 6. Here there is 1 2 3, the sum is 3. Here there is 1 2 3, the sum is 3. Can you get some peculiarity in this question? Yeah, the peculiarity of these values is that they are all divisible by 3. When I do percentage 3, that means the remainder. When we do x percentage 3, when x is the individual sums of the bits present at a given location, that will be 0 for this array. If I remove the odd element, the odd one out element, I will get these kind of sum. The reason being, if let's say a given number contributes 1 at a given position, let's say 1, it has contributed 1 at the one position, like the last position, the last element, the last location. So it is not just going to contribute a single one, it's going to contribute 3 ones, because the 1 is present thrice. So when it is present thrice, this, so in the first repetition, that will give 1, that will add 1 in this location. The second repetition will also have 1 in this position because it's the same number, so it will be having the same binary representation. The third one will also be adding 1 at the same location. So if a number is contributing 1 at a given location, it has to contribute at least 3. If it is contributing 0 at a given location, it will contribute 0, right? So every element contributes either 3 or 0. So if so there could be x elements that contribute 3 to the solution and y elements that contribute 0, such that x plus y should be n minus 1 in this case. You don't have to understand all of this. So if there are x elements that are contributing 3 to this location, so what should be the kind or the nature of this? It should be either 3x if there are x elements contributing 3, or it should be 3y, or it should be 3z, so on and so forth. So let me just erase all of this and give you the solution quickly. So it's 0 1 0, it's 0 1 0. You can see here, so the sum could be either 3x or 3y or 3z. So if my this unique number, the solution number, if it has, let's say this is 2, so it's 0 1 0 in this case. So what should be so if it is added in here, so that will also contribute the final sums, and the sum value would be here at this location, it will be 3x, it should be 3y plus 1, and it is 3z, right? It's 3y1 plus 1 because it is contributing 1 at this location. These are 0 contributions, so they remain as it is. So wherever it will be having 1 at whichever location, it will make the sum 3y plus 1, else they remain the same as what they were before, so 3x and 3z in this case. So at the locations where it is adding 1, when we do percentage 3, we'll get 1. At the locations where it is not adding 1, that is it is having 0, we'll just get percentage 3 as 0. That will be the hint for the solution, right? So we do the sum. So let me write the stepwise procedure. We do the sum first, then we do percentage 3 of the sum, and if it is equal to 1, we add 1 at that location and the answer, right, at location. So that is what we will see. We have, oh okay, so this is the previous solution that I was doing. This is the new solution, right? So we have a vector of 32 values, right? So these 32 integer values, they will represent the sum of bits at ith location. Here the I is 0 from 0 to 31, so it represents 32 bits. So we will have 32 sums here, right? So then for each bit, for each I, we are traversing basically the entire input array, this big A, this capital A we are traversing, and for for each element, what we are trying to find out is, we are trying to find out whether it is having 1 at I plus 1th location, at last I plus 1th location. How are we doing that? When we do 1 left shifted I times, we get 1 with I zeros following it, okay, and then the initial zeros are there. So if my answer like AJ, when I do AND with this, so what will I get? I will get this, if it will be having 1 at this location, that is the last I plus 1 at location, from the last if you count the first, if that is first. So if it is having 1, then we'll get the same number back. We'll get this same number back. We'll get the same number back. Oh shit. Should have been better if I could have just, so I mean this, we could get the same number back with I get zeros following the 1, so that is the same number. 1 left shifted I times, we are getting back here. The condition is that upon and doing an AND operation with this number AJ, we are getting the same number back. It means that AJ has 1 at that location. If we will not get, if we have, it has 0 at that location, we'll get all zeros as the answer. So that will not satisfy this condition. It means that AJ has 1 in this location. That means that will contribute to the sum. So we are just adding that to the AI. So we are just now finding the sum of bits, right? Sum of bits at a given location for all numbers, okay? So we are finding here the sum. So in this for loop we will be finding the sum of all the j's for a given I. So after this for loop is over, we have found out the solution. So these are just the debugging commented lines, so don't be bothered by them. Now what we do is that after we have found the sum for ith location, we just do %3 because that is what is of concern to us. Once we get the reminder, if that reminder is 1, we add 1 at that location for our answer. So answer or answer is 0 initially, right? When you do or with this number 0 or initial zeros, then 1, and then I 0 at the end. So when we do or with that, so that means that at this location, having I trailing bits, at this location we will be getting 1 in our solution. So answer will have 1 at those locations where we are getting ai %3 equal to 0. So that is our solution for this answer. I hope you have understood everything clearly, and I would like to want you to go through this once again and try to code it yourself. If you have any doubts, ask it in the comment section below. Also, you could give us suggestions about how we can improve our videos further for you guys. This is Dinesh Mohanty signing off. Before that, I would also like to mention that you can find the solution in the GitHub repository, and the link to the question, the links are provided in the description section below. Thank you. We'll have another 2 solutions that we'll be discussing in the next video. Try to understand how this is happening by looking at the code, take a snapshot, and that will be a hint for you maybe. Thank you and have a nice day. Wait till the next video comes up.